Hi guys, this is Miss Scott. So here we go. Today you're going to learn how to prove if two triangles are congruent using 5 new theorems. So you're going to understand what SSS, SAS, HL, ASA, and AAS mean fairly soon. Your EQ is how do you prove two triangles are congruent? And those abbreviations are going to help us out with that. The first one is the side-side-side congruence postulate. That's where the SSS comes from in our title. So that just tells us if 3 sides of one triangle, 1, 2, 3, are congruent to 3 sides of another triangle, 1, 2, 3, then the triangles are congruent. All right. The second one tells us if 2 sides and an included angle, which means between the 2 sides of one triangle, are congruent to 2 sides and an included angle of another triangle, then the triangles are congruent. So for example, you got 2 sides and the included angle here are congruent to 2 sides and the included angle here, then these triangles are congruent. So we can put a congruent symbol in our first one as well. And we don't want to write out side angle side every time, so we call this one SAS. All right. Our next 3 theorems rather, there is a theorem for angle side angle, which tells us if 2 angles, so this angle and this angle, and the included side, which means the side between those 2 angles of one triangle, are congruent to 2 angles and the included side for another triangle, then the 2 triangles are congruent. And we don't want to write out angle side angle, so we use ASA. All right, moving right along here. The angle side congruence postulate tells us if 2 angles, so I've got 2 angles, and a non-included side, so for example, this would not be included, it's not between, of one triangle are congruent to 2 angles, and a non-included side of another triangle, then those triangles are, you guessed it, congruent. All right, the last one only works for right triangles. So we're going to point that out very, very clearly. This one is only for right triangles. So you cannot use it for any other triangle than right triangles. But it tells us that if the hypotenuse, which is this side, and a leg of a right triangle, so a leg, and I have a right triangle, would be one of the 2 sides that makes the right angle. So if those are congruent to the hypotenuse and the corresponding leg, so remember the matching leg, not left, the matching leg, so that would match here, of another right triangle, then those 2 triangles are congruent. These are so important. We're going to use these until you're dreaming about them. So here we go. Oh, one last thing. These last 2 postulates, we can abbreviate angle side, AAS, and the last one we can abbreviate as HL. So that's where those abbreviations in the title were coming from. Okay, let's use these to do some practice. So we're going to decide whether the triangles are congruent. If so, state the postulate or theorem. So I've got a side, I got this side goes with this side, and I got this side goes with this side. So I've got a bunch of sides. So these are congruent because of side, side, side. All right, let's look at another one here. I've got, this is a right triangle. So I know that that's a right angle. I don't have the hypotenuse though. I don't know what that is. But I do have a side, and then this included angle, and then another side. And then I have this side, same as that one, and an included angle, and another side. So it doesn't matter that this is a right angle. I could have just as easily said this is congruent to this. It's both 90. So that is actually side, angle, side. So don't think that just because it's a right triangle, it has to be hypotenuse leg. That's not true. It could be any of the other four if it's a right triangle. All right, last one we have is, I've got this side and this side, and those are actually the included sides. So let's take a look. I've got an angle, and then I got a side and another angle. So I've got an angle, I've got a side, I've got an angle. I've got the same angle, I've got a side, and I've got another angle. So these are congruent by angle, side, angle. So we've just kind of used those a little bit. We'll get the hang of it. All right, let's go to some interesting parts here. So sometimes the congruent parts are hidden inside of the picture. So if you have a situation where there's a shared side, that side is congruent to itself, because we know HG is congruent to HG. If you remember, that's the reflexive property. So the reflexive property helps us out here. Sometimes we have shared sides that are congruent to themselves. All right. And also, you might run into vertical angles. So if you remember from past lessons, this angle is congruent to this angle because vertical angles are congruent. So this would be angle LMK would be congruent to angle, what would it be, NMP, because we know vertical angles are congruent. All right, so sometimes the congruent stuff will be hidden. And we're going to look at some examples with hidden parts. Okay, so we have example 4 here. Notice I've got a hidden side. So this is a side, and then I'm going to put an S here to show that. This right here is an angle, and then I have another side. So if that side and this angle are congruent to this side, these are congruent by side, angle, side. All right, if we look at our next example, I've got that shared side, and then I have this angle and this angle. Well, I really don't have enough info. I would need either another angle or another side, because they only give us this and then this angle, and then this and this angle here. So they only give me a side and an angle in each triangle. So I don't have enough info. I need more to prove that those are congruent. Okay, let's move along to example 6. I've got this hidden angle here. Those are vertical angles. So now I've got side, angle, side. I have the same side, angle, side here. So these are congruent by side, angle, side. All right, next one, we have again a shared side, so it's congruent to itself. So notice all the sides are filled in. So this would be yes by side, side, side. Okay, let's look at our next example. Looks like we have a hidden angle here. These vertical angles are congruent to each other kind of looks like a bow tie. And then this side and this side are not in between our two angles, so we would call this the non-included side. And if we have the angle and the non-included side, that is the angle side postulate. So we do have enough information there. Okay, if we take a look here at number 9, there's a shared side here. That is a right triangle, and what we just marked in the middle is the hypotenuse, and then this leg and this leg correspond and they're congruent. So in this case, this is what HL would allow us to say those are congruent. All right, last one here. This shared side is the included side between these congruent angles and this congruent angle. So that would be yes by angle side angle. All right, so there's quite a few examples for you. All right, one more section here. We're going to state what additional information is required in order to know that the triangles are congruent for the reason given. Then write a congruent statement for the triangles. So in example 11, they want us to use side, 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 but they only gave us two sides. So we're going to state what additional information is required in order to know that the triangles are congruent. All right, well, we would also need to know that this side was congruent to this side. So we'd need to know FD is congruent to WY. And if we knew that, then we could write a congruent statement for the triangles. So triangle FDE would be congruent to triangle WYX. All right, let's try that again. Example 12. I'm going to go back to blue so I can keep this organized. They want us to use side, angle, side. Well, they only give us the shared side and then this angle and this angle. So I'd have to know that LM is congruent to MH for those to have side, angle, side. So that's what else I need to know. I need to know LM is congruent to HM. And if I knew that, then I could write a congruent statement saying that triangle LMN is congruent to triangle HMN. All right, last example, we're going to use HL, hypotenuse leg. So in order for us to say these are congruent, I have the hypotenuse marked, but I would need to know one of the legs is congruent to the other. So it could be this and this. So I could say RS is congruent to YS, or I didn't have to do that. I could have just as easily said QS is congruent to XS. Sounds like excess. All right. So you got two choices there. Pick one, whatever one makes more sense for you. And then once we know those two triangles are congruent, we can write a congruent statement. Triangle QRS, that one on the top, would be congruent to triangle XYS, that one on the bottom. Okay, well, thank you guys for watching. We're going to do a lot of practice with these types of postulates where we show two triangles are congruent to each other. So just keep practicing. If you guys have questions or comments, you can leave those down below. And don't forget to subscribe to my channel. We'll see you guys next time.